Finally, what we're going to do in this video is talk about photon maps. So what are photon maps? Well, when mental ray makes all its global illumination calculations, believe it or not, mental ray can take that data and information and save it out to a file on the hard drive of your workstation. This is very important because it allows us to reuse the same photon map file over and over again, which can reduce render times. So instead of calculating these 3 million photons we have here over and over and over again, which takes a pretty long time, we can calculate it once and then that's it. We don't have to calculate it again. This is actually very good for when you're working on architectural visualizations, walkthroughs, or any type of circumstance where nothing in the scene changes. You just have a camera doing a fly through or anything like that. You can actually take advantage of this feature and get your rendering done much faster. So how do we do this? Well, let's collapse all of these rollouts. You'll see there's a rollout down here called the reuse, and in parentheses says FG for final gather and GI, disk caching. Let's go ahead and open that up. We have two sections here. The top section deals with final gathering. What I'm going to do is I'm going to skip that section. I'm going to focus on the bottom section down here, which has to do with caustics and global illumination. Global illumination can be saved to a photon map. Now down here we don't have a lot of options. We basically only have two main options. Down here for setting up a file, and right here we get three options in this drop down box or this drop down list for different choices we have for dealing with the photon map. Okay, the default setting is off. Do not cache map the disk. What that means is that so far we've been using this option where mental ray has been calculating the GI on the fly but hasn't been saving it. There's no files pertaining to our global illumination on our hard drive, but we can change that. If we want, we can come over here and we can choose read-write photon map to map files, or we can set up read photons only from existing map files. Let's choose the first option here, which is read-write photons to map files. A save as window opens up that automatically saves in the render assets folder of your project directory. Okay, and it's going to save out as a PMap, photon map, and we can name this whatever we want. So let's go ahead and name this. Let's call this my photons, and we'll hit save, and you'll see the name pop up down here. Okay, and we have this little X icon on the right which deletes the file. We also have this button on the left which lets us browse and change the file, change the name of the file, or switch to a different one, whatever we want. And then we also have this button down here. It says generate photon map file now. Okay, there's two ways we can generate this photon map. We can either hit render in the render frame window and render this out, or we can skip the render and just do generate photon map file now. If we do that, what's going to happen is mental ray is not going to render out the scene. What it's going to do is calculate the photon map, and that's it. So let's go ahead and hit that. Let's hit that button, and now the map that we just named to my photons is being created, as we can see here in the render progression window. And when it finishes, right about now, okay, so it's done. It rendered out the photon map file. Now, if we click on the browse button over here, we can see that yes, there is a myphotons.pmap saved in the render assets folder of my project. Let's go ahead and right click on this window and let's switch to view details. So we can see the size. We can see that the size of this photon map is about 60 megabytes, which is a pretty sizable photon map. It's a pretty good size, 60 megs. Okay, so these photon maps can be pretty big depending on how many photons are stored. Obviously, if there's less photons stored on the photon map, it's smaller. If there's more, like 3 or 4 or 5 million, it's going to be larger and larger and larger. Okay, so let's go ahead and hit cancel. Now that there's a photon map that's been created and it's loaded up right now, and my option is set to read-write photons to map files, what I'm going to be able to do is just hit the render button over here, and you'll notice that mental ray is going to go straight to rendering. It's not calculating a photon map because it's already loaded up right over here in this option. And this saves a lot of time because I can just get straight to rendering. I don't have to go ahead and render out a 3 million photon map. Okay, so that's actually pretty useful. Down here we do have an option for read photons only from existing map files. So what's that option for? Well, it pretty much does the same thing. What we can do is switch to that option. we can load up a photon map file like my photons, for example, hit save, and then we can render out, and it's going to go ahead and read that photon map and just go straight to rendering. In this mode, when you have it set to read photons only from existing map files, global illumination will not be calculated at all when you go ahead and render. When you're in the second mode here, which is the read-write photons to map files, if you have a map file here selected or written down, so if we create a different name for photon map but it doesn't exist, it's going to go ahead and calculate it. Okay, so that's the difference between those two modes. If we don't want our photon map anymore, we can hit this little X icon here to delete it, and then we can generate a new one simply by hitting the generate photon map file now. Alright, so now that you know how to create a photon map file, let's have a look at how to optimize a photon map file. Right now, I'm going to say that we have a problem. What is the problem? Well, let's hit the browse button right here, and we're going to see here my photons. This photon map, this P map, is 60 megabytes. Let's say my boss just came and said, "What are you, crazy? 60 megs? That's too big. The render farm can't take it. We're going to need something that's half that size, if not smaller." What are you going to do? Uh-oh. Well, let's go ahead and create a new photon map file. I'm going to make a new name here. And a new one, I'm going to call it, say, well, let's call it Tiny. I guess Tiny Map will work, because we're going to make a smaller photon map, and we'll hit save. Okay. Now this Tiny Map just exists in name. It hasn't been actually created yet. I'm not going to create it just yet. Here's what I'm going to do to make it smaller. Let's collapse that rollout. Let's go back to the global illumination rollout over here. Now if you remember in a previous video when I was going over some of these settings, I did mention that this setting right here, the merge nearby photons, which saves memory, I was going to skip it, and I did, and I was going to come back to it later. Well, the later is now. I'm coming back to it now to show you how this works. Okay, so here we have this option that says merge nearby photons. So what in the world does that mean? Well, let's turn it on. Okay, what this option does is it actually looks at the scene and mentally decides, okay, these photons are really close to each other, so let's go ahead and merge them together and average out their brightness and their contribution, and let's go ahead and save ourselves some memory. Okay, memory being that it's going to save the file size. This file size is going to be smaller. Okay, now by default it's set to 0 centimeters. This is not good. You don't want it to be set to 0. This can cause problems. So we want to use a size. So the question is, what size should we use to merge these nearby photons? Well, you can use a lot of different sizes. It really depends on your scene. In this case, I'm going to use a very small number. You don't want to use a very large number, because the problem is if you use a very large number, like let's say if we use a number like 10, what's going to end up happening is it's going to, editor, there was a car in the background, editing is starting in 3, 2, 1. If you use a very large number like 10, for example, what's going to happen is that it's going to start to merge photons that are really far apart, and that's a bad thing. That's a bad thing because it's going to create splotching in your scene and a lot of artifacting, which is no good. We'll be back at square one. So what we want to do is use a very small number. Let's use a number like 0.1. 0.1. It's a very small number. So only photons that are practically on top of each other will be merged. And this is going to save ourselves a lot of photon map space. Okay, now that I've set up my nearby photon setting to 0.1, let's go back to the reuse rollout over here. And let's go ahead and generate the photon map file for Tiny Map. So let's hit this button. It's going to go ahead and start generating it. You can see it's doing a photon emission. Now the first thing you're going to notice is that, the photon emission is actually taking a lot longer than before. That's one of the drawbacks to using the merge function. When you merge photons together, the good side is your photon map will be a lot smaller than before. The downside to it, photon emission is going to take a lot longer than before. Maybe twice as long as before. Maybe sometimes in some cases, depending on how many photons in your scene and how your settings are set up, it could take even longer. So it's not taking terribly long here to render out the photon emission, but we'll get to see what happens when it's finished here. I'm just going to pause the video and come back as soon as it's done so you don't have to watch this. So I finished calculating the photon emission there for Tiny Map. Now what I'm going to do is hit the browse button, and I'm going to right click here and go to view and switch to details mode. And now we can see that the Tiny Map is only about 15 megabytes. So the Tiny Map ended up being less than half of the size. In fact, it ended up being about a quarter of the size of the original Photon Map. So what's the benefit to it? What's the benefit to having a smaller Photon Map? Well, the benefit is if you're working with a render farm and you have to render across several systems, what's going to happen is if your Photon Map is too large, it can cause network traffic problems and slowdowns. If you're dealing with a very small Photon Map, like let's say this 15 megabyte file, you're going to be able to render out a lot more efficiently, faster. You're also going to have a much more stable render farm going on here in the background. So it's very important to keep your Photon Map as small as possible and as friendly as possible. So what I'm going to do is just hit cancel on that. So you can see how the merge function is actually pretty useful when working with Photon Map files. Okay, so I'm going to leave these options alone. I'm going to just read off that Tiny Map file here. Let's go ahead and hit render here in the render frame window. See what we get. As we can see, the result looks pretty good. Hey, what's up? Mm-hmm. Okay, awesome. Okay, well, I'm just trying to iron out the deal with these people, and I'm basically just waiting on the word if they're going to say no or go. So I'll let you know. That's the thing. I'm talking to them now. I'm waiting for them to make a decision on that. So they'll let me know. When they let me know, I'll let you know. Mm-hmm. What? Yeah, sure. I guess.
Okay, cool. Yay, sorry, that's
Okay.
So that's a good time so we can meet so you can tell me about the file. It's in your group.
Right. Yeah, I'm just waiting to see what they say.
Alright?
Okay. All right. All right. Talk to you later. Thanks. Bye. Okay, editor, edit that. The video starting again in 3, 2, 1. So we can see that we don't have a lot of splotching here. Actually, we don't have any splotching. Merging the photons didn't affect the quality of the photon map at all. Now, as a final note in this video, I want to show you something here. Let me go ahead and close this over here. Let me also go to the render frame window. I'm going to close out the UI here, the user interface for the render frame window. Just click on this button over here on the right, and that'll turn off the UI there. It'll toggle it on or off. Okay, let's turn it off. Global illumination photon mapping is not view dependent. What that means is that after you go ahead and render out this global illumination solution, everything just works. So the photons that are behind the camera view right now, to the side, outside of the view, behind objects, in front of objects, on top, on the bottom, everywhere, just works. So for example, if I go ahead and turn my camera view around here and look at the back of the room, just look at another angle, and I were to go ahead and render this out with this map frozen in place, you notice that mental ray is not calculating the global illumination over and over again, and I'm getting global illumination all over the scene. So it doesn't matter if the camera didn't get something inside of its view, it's still going to render out with the photon mapping. So photon mapping is not view dependent. It's very important to know the difference between view dependency and something that's not view dependent. And photon mapping is not view dependent, so you can go ahead and do a photon map for your entire scene and then just render this out from any angle you want. And this is perfect for when working on architectural visualizations, walkthroughs, design visualizations, that sort of thing. This works out very, very well. Alright, so I hope you enjoyed global illumination and it made a lot of sense to you. What we're going to do is move from here and we're going to continue talking with global illumination, but this time we're not going to deal with such a simple example like this room. We're going to deal with a real production example to see what the challenges are run into problems and issues with global illumination in a real world production scene, and find out how to troubleshoot and how to solve problems on the go when you're working on a production scene. So we'll see you there. So I'll see you there.